Hello and welcome everyone. So today we are going to talk about one of the advanced concepts in SQL, which is recursive CTE. If you are a beginner, this might sound a little complicated at first, but if you already have some experience with SQL, trust me, recursive CTE will feel like a cakewalk after watching this video. Now, instead of jumping straight to the definition of recursive CTE, let me first set the context to help you understand why recursive CTE is important. For that, let me ask you a simple question. How would you generate a sequence of numbers starting from 1 to 5 in two different scenarios? In the first scenario, I am not putting any restriction on language or function. So you can easily solve this using simple loop or recursion in any programming language like Python, Java, etc. To demonstrate the same, I am using Python, and in first case to generate the sequence I will use loop. So for that I am writing for item in range, and then here I am defining my starting point, which is 1, and ending point is 6 because it is exclusive, and then I am print item. If I will run this program, it is going to generate number for me, you can see. Now in second case, I am going to generate the same sequence by using the concept called recursion in functional programming. We are going to explore recursion in detail just a short while, but for now let me define recursion in one simple line. So recursion is a technique where function calls itself. Let's see how that actually works. For that, I am defining one function SQL with parameter n with value of 1. Now I am checking the condition like if n equal to 6, then I am returning back the function. But in case if it is not 6, then I am printing the value of n, and then again calling my original function sqn with incremented parameter like n plus 1. Now if I will call my sqn function, it is going to give me a desired sequence. So you can see this one. So it seems super easy, right? But now let me bring the second scenario to make it interesting. What if I say do the same thing in SQL but without using any built-in function like generate series or any other function? Now it become tricky, right? But guys, that's exactly where the recursive CT come into picture to solve this kind of problems. Let's see how this works with the same example just to get a sense of how recursion work in SQL. So I have written this recursive CT. If you observe carefully here, you will notice that the query refers to itself, which is the basic phenomena of recursion. We are going to see recursion in detail in a short while, but for now let's execute this query. So you can see it generates the same sequence. Now I believe you have got some idea of why recursive CTE are important. So let's dive deeper and explore the intricate details in a structured way, which I will be covering under three simple sections. That is, what exactly is a recursive CTE, syntax of recursive CTE, and then practical use case example of recursive CTE. So first thing first, what exactly is a recursive CTE? So recursive CTE is a SQL feature that allows a query to repeatedly refer to itself. In simple words, it's a way to perform recursion within SQL. I hope this definition makes sense to you, especially since we have already seen a quick example just before this. And guys, just a quick note, I have already written a detailed post about this on Medium. I highly recommend you to check it out. You will find link in the description. Now let us move on to the next section, which is the standard syntax of recursive CTE. So I have drawn a standard CTE query structure here to help you visualize it clearly. But first let us quickly understand how a recursive CTE differs from the regular CTE structure. So in the case of regular CTE, we simply write with then CTE name as, and inside the bracket we write SQL query which has set of instruction. But in case of recursive CTE, this query which is inside the bracket has three essential parts. First is the anchor member, which acts as an initiation or starting point. Second is the recursive member, that's where recursion happens. And third is the termination condition, which ensure that the recursion stop at right point, preventing it from an infinite loop. So this is the main structural difference between recursive CTE and regular CTE. Now next, if you observe this recursive CTE closely, it logically resembles how recursion works in Python or any other programming language. For example, the anchor member is similar to initial code block in a Python recursive function, and the recursive member works just like a function calling itself inside own definition, and the termination condition function the same way as the base case in the Python, which stop further recursive calls. Now I believe you have got familiar enough with the structural part, so let us move on to some practical examples. In real world scenarios, recursive CTs are commonly used for generating sequences, for example, numbers or date, solving repetitive patterns like printing star or shapes, processing hierarchical or tree-like structures such as employee-manager relationships. Now let us explore each of these examples one by one. So let's begin with the first use case example, generating sequences. But before we start, just a quick note, I am using MS SQL Server here, so the syntax might differ slightly across other databases. However, the core logic will remain exactly the same no matter which database you are working with. And don't worry, once we go through all the use case example, I will also show you how to write the same logic in MySQL as well as in PostgreSQL. Now back to the point, let's take a look at our example, that is how to generate sequence of numbers from 1 to 5 using recursive CTE. So now I believe you are familiar enough with the structure of recursive CTE. So let's start directly writing query. So first I have to define the recursive CTE. So for that I am writing with then recursive CTE name, and here I am giving it as temporary, then as clause, and I'm starting one bracket, and inside this bracket I'm going to have anchor member, recursive member, then termination check. Now anchor member defined our base query or a starting point, and in this case the starting point is 1. So for that I am writing select 1 and I am giving alias to it as n. Now after executing this base query, the result will be stored in this temporary table. Now recursion process will come into picture, and the recursion logic is very simple, like whatever the output we are getting from last recursion, I have to increment it by 1. So for that I am writing select n plus 1, and this output we are getting from obviously this temporary table. So I am writing from temporary table. Now this is our anchor member and this is our recursive member. To make a relation between both query, I have to write union all or union only. You can write anything like union or union all. I am writing here union all. Now this both will form a kind of infinite loop. So to stop this, I have to give termination condition, and in this case the termination condition would be defined under where clause. So I'm writing where n is less than 5. Why n is less than 5? So for that, wait a moment. I will explain this condition while explaining its internal working. For now, our CT part is over. Now I have to write our main query. So for that I am writing select, then everything I am selecting from my temporary table. So now if I will execute this query, it is going to give me our desired result. So let's execute. So you can see it has yielded this desired result. Now let us understand its internal working in order to get more clarity on this concept. So guys, I have broken down this internal working in different steps. So let's understand each step in detail. In first step, SQL will read this query and it will identify that it is a recursive CT because here temporary table is referred to itself. After recognition of this as a recursive CT, it will search for the anchor member, and in this case the anchor member is this one. So it will execute it, and after execution it is going to produce initial result set, which is going to be like this one. and then this result set will be stored in this temporary table, and after this the iteration process will begin using this temporary table. So now let's look each iteration in detail. So for first iteration, this recursive query is going to be executed, and in this case the temporary table is this one. So first from temporary table the value of n will be selected, and in this case the value of n is 1. Now it will check where condition. So in this case 1 is less than 5, so it will become true. Then next n plus 1 will be executed. So after execution this, now the value will become 2. So if we see the result set after first iteration, it is going to be like this one. Now second iteration will begin, and for second iteration the temporary table is going to be this one. And in this case the value of n will be 2 because we are taking value of n as a last iteration. Now this recursive query will be executed and process is almost same as previous one. So from temporary table, we are going to select the value of n. So in this case, the value of n is 2. Now this condition will be checked. So 2 is less than 5, true. Then again n plus 1 will be implemented. So in this case, 2 plus 1 is going to be 3. So after second iteration, we are going to have our temporary table result set something like this one. Now third iteration will begin, and for third iteration the temporary table is going to be this one, and in this case the last iteration value is 3, which is the value of n. So again for third iteration this recursive query will be executed. So from temporary table we are going to select n, and in this case the value of last iteration is 3. Then 3 will be selected, and then again where clause will be executed, and in this case 3 is less than 5, so this condition will become true. Now n plus 1 will be executed, so 3 plus 1 is going to be 4. So after third iteration the result set we are going to have something like this one. Now fourth iteration will begin, and for fourth iteration the temporary table is going to be this one, and in this case the last iteration value is 4. So again for fourth iteration this recursive query will be executed. So from temporary table the value of n will be selected, and in this case the last iteration value is 4. So n will become 4. Then again this condition will be executed, and in this case 4 is less than 5, so it will become true. Now this n plus 1 will be executed, so 4 plus 1 will become 5. So now we are going to have temporary table something like this one after fourth iteration. Now fifth iteration will begin, and for fifth iteration the temporary table is going to be this one, and in this case the value of n will become 5 because this is the value of last iteration. So again for fifth iteration this recursive query will be executed. So from temporary table the value of n will be selected, which is 5. So again this condition will be checked, and here 5 is not less than 5. So this condition will become false and recursion will stop. So after fifth iteration we are going to have our temporary table this one. Now after this one the main query will be executed, and in this case the main query is this one. Now if I will run this whole query, then I am going to get this output in my screen. So let's execute and see. So as you can see, I am getting the same output on my screen. I hope the internal working of this recursive CT is clear to you now. Now let's move to another example. But this time we will generate a sequence of date to make this concept even more clear. So for this I am going to copy this same query because logic is going to be the same here. Only minor changes will be made inside the anchor member as well as inside the recursive member. So let's see what all those changes are going to be. So for that I have pasted this same query. Now let's see what changes I am going to do inside the anchor member. So earlier our starting point was 1, but now I want starting point as today's date. So to get the today's date I will use getDate function because this is a standard function of SQL Server. If I will execute it, I am going to get date along with time, but I want only date part, so I will use cast function to cast this output as date. Now if again I will execute it, I am going to get only the date. So now our starting point will become this one. Next, we have to do changes inside the recursive member. Since earlier we were incrementing the value of n by 1 for every iteration, in the same way we have to increment the date by 1 for every iteration. So to do that we have to use date add function because normal addition is not supported in case of date function. So I am writing date add, then I'm passing first argument as date, and then I'm mentioning how many days. So I want 1 day increment for every iteration. So here I am mentioning 1, then whatever the value is coming from previous iteration. But in this way it will keep incrementing the date of previous iteration by 1 day and will form an infinite loop. So to avoid infinite loop we have to define the termination condition or stop condition, which will be defined inside the where clause. Let's say I want the iteration to stop after 5 days from the current date, which in this case is 16th July 2025. So to define it, first we have to get the current date. So for that I am using this function, as we have already seen that it is going to give me my current date. Next we have to add 5 days in the current date. So for that I am using date add function, and here I am mentioning first argument as days and second argument how many days I want. So in this case I want 5 days, so I will pass 5. Now this whole things is going to give me last or stopping condition. Now if I will run this whole query, it is going to give me my desired sequence of date. Let's run and see the result. So you can see the starting date is today's date and stopping date is 16th July. So now I hope you have understood both examples, and I believe it's now clear how recursive query make sequence generation simple and powerful. Now let's move on to another interesting use case of recursive query, that is pattern generation. Let us suppose you want to generate this pattern. Now guys, generating this type of pattern is actually very easy, especially if you have understood our very first example of generating a sequence of numbers. To understand how it works, let us go back to our very first query we wrote, and now let me run this query again over here. Then right now I am getting a sequence of number starting from 1 and ending at 5. Now imagine what if I replace each number with star. For example, 1 with 1 star, 2 with 2 star, and so on. And if I will do that for all the numbers, then I will get exactly same pattern which we are trying to generate in this example. Let's see how we can achieve that. So to do this, we just need to make a small modification in the final query. So let's see what are all those modifications. So first thing, I'm going to use replicate function, and this function is a standard function of MySQL server. It takes two arguments. First, the string which we want to replicate, and in this case, it is going to be star. Then the frequency, and for frequency I am passing the value of n. And now what it will do, for first line it is going to give me 1 star, for second line it will print 2 star, likewise for rest of the rows. Now let's run this and see the result how it is going to implement this thing. So you can see we are getting the star. Let's make some minor modification here. First thing, alias to it as pattern. Next I'm adding some spaces so that it will be more visible and spacious. Now let's run it again. So you can see we are getting the desired pattern. So I hope it's clear now how recursive queries make it really easy to handle pattern generation problem. Now let's move on to another very common and practical use case of recursive query, which is solving hierarchical or tree-like problems such as employee manager hierarchy. Let's say we have employees table that contains employee ID, name and their manager ID. Now if you will observe this table, you're gonna find that Rajesh has a manager ID of null, which means he does not report to anyone. So he is the CEO. And Anuj report to Rajesh. Yes and Ravi report to Anuj. Likewise, Simran report to Yes. If we draw the hierarchy or level wise diagram, it would look something like this, where Rajesh is at level 1 or top level, Anuj is at level 2, Yes and Ravi are at level 3, and Simran is at level 4 or bottom level. Now to build this hierarchy dynamically in SQL, we have to use recursive CTE. Let me break it down step by step. But let me first show you the employees table which I have already created. So for that, here I am writing select and then all column from my employee table. Let me execute this one. So this table we are having. Next I will copy the structure of very first recursive query which we have used. Because the pattern is similar, we will just need to modify logic a bit. So let me copy from here and paste it here. Now let's transform this for our employees hierarchy example. So let's start with modifying our anchor member. Earlier anchor member was this one, where the starting point was 1. But in this employee table, the starting point or tree root is the CEO of the company. That is Rajesh. And if we put it logically, it refers to the employee whose manager ID is null. Let's write this part in the query to get the anchor member or starting point of the hierarchy. For that, I am removing this part and I'm selecting employee ID, name and manager ID from employee table. Next, I am filtering those employee whose manager ID is null. So I'm writing where manager ID is null. Now, if I will execute this part of the query, it will give only this employee. So let's run and see. So here we got the employee whose manager ID is null. And since he is the CEO, so I am assigning it as label 1. Now let's run it again and see the result. So you can see this employee got label 1. And with that we have defined our anchor member or starting point of the hierarchy. Now let's move on to second part where we will define the recursive member of the query, that is this part. So earlier the logic was pretty straightforward. We were simply incrementing the value of n with each iteration. But in this case, the logic behind the recursive call is slightly complex and different. Here we need to fetch the employee who report to the previous level. For example, in this case, the first recursive call, we want to employee who report to Rajesh. To achieve this, we will use join where we will map each employee to their manager based on the manager ID. Let's see how we can write the query for this thing. But let me first copy this part and put it here so that we can realize our original table and the anchor member table. Let me execute here. So this is our original table and this is our anchor table, and after a while I will explain its working, but whatever the execution happen for anchor member will be stored in this temporary table. Just remember that one. Now to write the recursive query we have to join our employee table with the anchor table, and the logic behind this as I have already explained. Now to do this I am copying this part of the query because it is almost same, and here I am doing some changes like I am giving alias to employee table as E. Now I have to join this with this anchor table which is stored in this temporary table. So I am writing join with temp table and I am giving alias to it as T. Now the basis for joining these two tables is the manager ID of the employee table and the employee ID of the temporary table. So I am writing on E dot manager ID equal to T dot employee ID. Next, we need to mention here from which table these column are coming from, because in both table we have same column. So I'm telling these column are coming from my employee table. So I'm writing E dot employee ID, E dot employee name and E dot manager ID. Next, I need to increment the label for every iteration. So I'm writing label plus 1, that is the previous label, and I am incrementing it by 1. Next, coming to the termination check, here no need to mention any specific termination condition because Once this join get failed, the recursive query automatically will stop. I will explain in a while explaining its working. Now let's remove extra part from here so that we can run this query. So I'm removing this thing and this also not required. Now this is our final query. Let's run and see the result. So you can see Rajesh got label 1, Anuj got label 2 because he is reporting to Rajesh. Yes and Ravi got label 3 because they are reporting to Anuj, and Simiran got label 4 because she is reporting to Yes. Now if we draw these label as a tree structure, we will get the same hierarchy just like this one. Now let's understand its internal execution. So the internal execution is almost the same as our earlier sequence generation, only this time we are matching employees to their managers instead of just adding number. But let's quickly understand its working. So when SQL engine will read this query, it will find that it is a recursive query because here temporary table is referring to itself. So after this, it will try to find out the anchor member, and once it will execute it, and after execution it will store the result into temporary table. So if we realize for this case, so we are going to get the anchor member table something like this one. After this, the recursive query will start executing until this join condition will not get failed. For example, for first iteration, it will find out all those employees who are reporting to Rajesh. And in this case, the Anuj is reporting to Rajesh. So he will be fetched here, and then we have to increase its label. So earlier label is for Rajesh is 1, so we are going to increment it by 1. So its label become 2. Now the second iteration will begin and it will find out all those employees who are reporting to Anuj. And in this case, Yes and Ravi both are reporting to Anuj. So these both employees will get fetched and their label will be incremented. So its previous label is 2, so it will become 3 here. Now next iteration will begin and it will find out all those employees who are reporting to Yes, that is 3. So in this case, only Simran is there who is reporting to Yes. So she will get fetched and the label also will be incremented. So the last label is 3. So now it will become 3 plus 1, that is 4. Next iteration, it will try to find out all those employees who are reporting to Simran. But here no employee exists who are reporting to Simran. So this join condition will get failed and the query execution will get stopped. So at the end, in the final table, we are having this thing which are stored in this temporary table. Hence, when we are executing our main query from temporary table, we are getting this result. Guys, since I don't have MySQL and PostgreSQL installed locally, I will be using online SQL compiler to show you how the recursive logic works in those databases. For that, I have copied the same query which we have executed in MS SQL Server for generating the sequence and generating the pattern. Now let's see what changes we have to make in both cases in case of MySQL Server. So for generating the sequence, let's see what changes we have to make in order to run this query in MySQL Server. So here we have to tell the database exclusively that this is a recursive query. So here we have to mention recursive. Rest logic is going to be the same. If I will execute this one, it will give me the correct sequence. So you can see. Now for generating the star pattern, the same things will be here also, but here we need to tell that this is a recursive, and next we have to use another function. Here replicate is not working, we have to use repeat. The rest logic is going to be the same. Now if I will execute this one, it will give me desired result. So you can see this is for generating the sequence and this is for generating the pattern. And for the PostgreSQL, the same query will work. So let's copy this query and change the compiler. So now I'm selecting PostgreSQL. So I have pasted this one. Let's run and see the result. So you can see we got the same output. Here we have not done anything. Whatever it is working in case of MySQL, the same query is working in the PostgreSQL. Hope you guys now have a clear understanding of entire recursion concept in SQL. If you enjoyed the video, do let me know in the comment, and if you haven't subscribed yet, please consider subscribing. Thank you for watching. See you in the next one.